sketching, basically just using everything we know from calculus and everything from the past, algebra 2, pre-calc, to graph a function. Okay. So let's start with this. Let's see what else is here. Yeah. So without the use of a graphing calculator, we can pretty much graph fairly accurately of this function. All right. So we're going to look at all of the following, and then we're going to plot a few points, sketch the graph. Okay. So here's our function: 3x to the fifth minus 20x cubed. I kind of grouped it into pre-calc and then calculus. So I'm starting here with these. All right, so here we go. Domain. Domain is all the x values that work for a function. This is a polynomial. Domains for those are always all the numbers. I'm going to be using interval notation for all of this, so you want to write a symbol for all the numbers you can, or negative infinity to infinity. Range. That's all the y values that work in your function. The degree here is 5, and so it's overall like an x cubed type, something to that effect. So it's going to hit all y values. Right? It's going to go on forever in both directions. So it's also negative infinity to infinity. Okay, I'm actually going to skip symmetry. Although it can be good, I think I'd rather focus on some other ones. Symmetry is more like you graph and then you're like, all right, well, it's reflected over the y-axis or around the origin. So I'm going to skip that one. All the others I'm going to do. Intercept. So that's x and y intercept. Let's start with the y. So I think that that last practice one yesterday we did intercepts. So if you remember, y-intercept is just where x is 0. X 0. So I'm plugging in 0 for x and evaluating. And it'll be 0. Or I guess you can put the points, the full point 0, 0. Okay, and the x-intercept we did, it was setting the y value equal to 0. So this is setting the function equal to 0. 20x cubed. Okay, so then we'll solve, let's say, I can take out an x cubed. Looks like the most I can take out. So I'll be left with the 3x squared minus 20. So right here, when we have x cubed equal to 0, we do a cube root, and we get 0. Here, little quick solve, I would set that equal to 0 and add 20 to both sides. Divide by 3. X squared equals 20 thirds, and then do a square root. So we get plus or minus radical 20 thirds. By the way, I try to make these so some of the values come out nice, but it's kind of impossible. At some point, either the derivative, the second derivative, or the original, it's kind of hard to get them all to be whole numbers. So at some point along here, there's going to be a few decimals. That's about 2.6, 2.58. So if we want to, let's see, go ahead and like the y-intercept was 0 or 0, 0. And these were the x-intercepts. So about 2.5, 2.6. So I'll just go ahead and plot those. Well, that's pretty much it for the pre-calc stuff. Everything from really algebra 2 and pre-calc. Good there? Anything to clarify? Questions? Now we're going to do all the calculus stuff. This is pretty much everything we've done. Asymptotes are also included here. I put it here with calculus because we did limits with that. That was unit 2. It also could kind of be in pre-calc. You did some asymptotes there. So. Okay, well, let's go on to the calculus part. So I'm going to need first derivative and second derivative. First derivative, 15x to the 4th minus 60x squared. I'm going to kind of do a side by side again. So second derivative I'm going to do right here. 4 times 15 is 60x cubed. And then let's see, minus 120x. Alright, we're ready to get most of everything else up there. We set them equal to 0, solve, number line. Okay, so let's do this one first. I can get a 15 and x squared. So here I'll be left with an x squared minus 4. So setting this one equal to 0, we would divide by 15, get 0 equals an x squared, and do a square root, we get 0. Here I'm going to get, I'm going to do a difference of squares, or you could just set it equal to 0 and add 4, and then do a square root, get plus or minus 2. So those are critical points. That was something I'd asked for. Yeah.
Wait, how'd you get the 15x squared to just be x? What'd you do?
Well, I divided by 15 first. So it would have been the
Oh, I
first
see.
one. So this is gone, and 0 divided by 15 is 0. Yeah. So that was critical points. Then I'm going to use them to get the increasing, decreasing, and local extrema and all that. So number line 0 to negative 2. So that gives us some easy values to choose. I'll choose 1, 3, negative 1, negative 3. Again, this is all first derivative that we're working in, so we plug these into the first derivative. Okay, I'll do a couple. I don't want to spend too much time. Let's do 1. If I plug in 1 here, it's just 1 times 15 minus 60 times 1. So that'll be a negative number. How about negative 1? Negative 1 to the 4th is still a positive number. So it'll be 1 times 15. Negative 1 squared is 1. So it'll still be 1 times negative 60. So that's still negative. If I do 3, I think these are going to be the positive ones. So if I plug in 3 here, 3 to the 4th, 81. 27, 81. 15 times 81. Minus 60 times 3 squared is 9. And this number is bigger. So it will be a positive. Negative 3 is going to be the exact same because when you square it and when you do the 4th power, it's positive. Alright, so let's write down the increasing, decreasing based on that. I'll get rid of my test values. Okay. And I'm going to choose increasing first positive. So it would be negative infinity to negative 2. Union 2 to infinity. Decreasing where our slopes were negative, negative 2 to 0. Union 0 to 2. Let's see what else that one. Okay, that was the second one. That's good. And actually, we can get the third one from this. So, third one is just, well, global extrema. It's a x cubed, x to the 5th type. There's no global. because it goes on forever. So I'll put global extrema none. There's no, basically that means there's no max or min. Like, no global max or min. Absolute. But there are some local ones. This is just the first derivative test. I just look and see where it changed, where the signs changed. So it was increasing, decreasing, so right there at -2, there's a local max. Decreasing to 0, but then it keeps decreasing, so nothing at 0. But then 2 and on, it increases. So at 2, there's a local max. So local extrema, I'll put, I'm gonna put 2 blank. This will be a local max. So what I'm gonna do is, I normally put at x equals 2. What's gonna be helpful though is to actually get the, like, where do I graph it? How do I know, because I'm gonna be drawing this, how do I know how far to go up to or down to? So I'm just gonna plug it in a minute to get the actual point. Okay, what did I say? There's a local min. Oh, this is -2. I'm sorry. Right. Yeah, sorry, -2 max. And then at 2, there's a min. So 2 something local min. Again, for now, you could just say at x equals 2 local min. But to finish up first derivative, I'm gonna plug those in just to get the actual value, so I know exactly how to graph my function. And then that will take us up to the third one, and we just got the second derivative. So let's see. Now this has been a little bit since we've done this. To get the actual maximum value, I'm going to plug 2 and -2 into the original. So that was the first section. If you go back, extreme values. Okay, so that was like we set equals 0. Got the these are the critical points. So we don't need 0 because it didn't change. I'm going to plug these into the original. This is where we like made table of values. Plug the critical points into the original. So let's plug in 2 and -2 into the original. All right, so if I plug in 2, 3 times 2 to the 5th minus 20 times 2 cubed. Let's see, 2, 4, 8, 16, 32. 2 to the 5th. 2 cubed is 8. So this should be 96 minus 160. So that'll be -64. Again, here's where, oh, actually I did it over here too. Oh, I'm sorry, that was 2, wasn't it? So here's where some of the values get a little challenging. But what I'm going to do to fix it is we're just going to go, so at 2, we're just going to put like, the x values are normal, 1, 2, 3. The y values on this grid, we're just going to have to make, the only key one we need is like -64. So I'll put it there. Then we'll put 64 there. So let's go back and do -2. It's going to plug in -2 to the original. The only thing that's going to change is some of the signs here. So let's see. -2 to the 5th power, that will make it a negative number. So it'll now be -96. And then -2 cubed will be a -8. And so now this will be a positive 160. So now when I add them, it's a positive 64. So, and a minute when I graph this. I'm just going to make it 64 just somewhere on there so that it works. Again, sometimes the numbers here are difficult to get perfect. Okay, that's it for our first derivative. We're close to done. Just second derivative with concavity, and then we'll basically have everything to graph. Anything so far though? Questions answered. Well, let's finish it off here. Second derivative. I'm going to go back up here, set it equal to 0, start factoring. Take out a 60x. And so I'll be left with x squared minus 2. So just as before, the first one we set equal to 0, and I would divide by 60, and I would get 0 equals x. And here, I would set it equal to 0 and add 2, and then do a square root. And so we get plus or minus radical 2. Radical 2 is about 1.4. Okay, so yeah, number line. 0, positive radical 2, negative radical 2. And we're working the second derivative, so I'm going to plug my test values into the second derivative. So again, radical 2 is like 1.4, so I can choose 1 and 2, and then negative 1 and negative 2. Okay, let's do a few of these, but I might fill in some of the rest. Let's plug in 1. Plug in the second derivative. 60 times 1 cubed is 60. 1 cubed is 1. Minus 120. And 1. Minus 120, so that's negative. If I change it to negative 1, well, this will be negative 1 cubed is now negative 60. Minus 120 times negative 1 is now positive 120. So that one will be positive. A similar thing happens with the 2's. I'll plug in 2 here. Let's see, 8 times 60 is 480. Minus 2 times 120 is 240. So this will be positive, then for the other one it'll be negative. Okay. I'm going to get rid of my test values. And then I can write my concave up and down intervals. Okay, so concave up is where it's plus here. So that would be negative radical 2 to 0. Union radical 2 to infinity. Concave down, negative, so it'll be negative infinity to negative radical 2. Union 0 to radical 2. Okay. And finally, points of inflection occur where the concavity changes. All of these change. So I'll say point of inflection at x equals negative radical 2, 0, and radical 2. Alright, well that was second derivative stuff. And then we use all this to graph. Any thoughts on the second derivative though? Points of inflection. The one thing I'm leaving off that I didn't do yet was asymptotes. But it's a polynomial. Polynomials don't have any asymptotes. So this one's just none for this one. What are their asymptotes? Well, mainly when it's rational functions. That's why you could have done this one with the pre-calc stuff from last year. Okay, well I'm going to plot a few points and sketch the graph. I've already plotted many of the ones, the y-intercept, the x-intercepts. Let's plot the local max and min. So there's at negative 264, there's a local max. Negative 2, 6, we call that one 64. And then there was a local min at 2, negative 64. I'm going to think about the overall shape of the graph. It's an x to the 5th type. Positive x to the 5th. So we know it's roughly starting down. It's going to go up through these points, down, and then back up. We know that, but I'm also going to follow, I'm going to follow this, increasing, decreasing, and the concavity. Okay. Now, last thing I'm going to do before I graph is I'm just going to make a little mark on my graph where the concavity changes. So at negative radical 2, that's about negative 1.4. At 0, I'm looking at these. And at radical 2, which is about 1.4. Okay. You don't have to do that. I'm just putting those there just so I know when to change it from concave up to concave down in the curve. Okay, so now I'm going to graph. So it's x to the 5th, so it's starting down, right, and going up. And it's going to go through our x-intercept there. And I'm also following this. It's increasing negative infinity and negative 2. So basically, it's increasing all the way to this local max. Should have a little more curve for that. But. All right, and it is concave down to start. So it's shaped like a frown all the way here. So now I will decrease. So I'm going back over. It's decreasing negative 2 to 0. It's decreasing. It's shaped like a frown. Let's see if I can do this. Now, I'm not going through that point. I'm not going through that there. It's just that's where concavity changes. So right here, I'm going to start to change the concavity, and it's going to go through. The next point it's going through is the origin. I want to change a little bit of this. Okay, so it's decreasing, but right here, the concavity changes. So now I'm going to make it more concave up. So yeah, basically it was like this. It was concave down, but right there I had to switch it. Now it's starting to go concave up, shaped like a cup. Let's check this over here. So it's concave up to 0. Next, it's going to be concave down, shaped like a frown, from 0 to radical 2. So it switches right here at 0. It's going to be concave down, shaped like a frown. It's also, what's it doing? It's decreasing, right? Yeah, it's still decreasing from 0 to 2. So it's going to concave down, shaped like a frown. But right here, that 1.4 radical 2 is going to switch and be concave up again. Okay, but it's still decreasing all the way to 2. So right here, it's just concavity, so it's shaped like a cup. Okay, we're almost done. Then it's increasing the rest of the way from 2 and on. And it is still, let's see, what am I going to have? Yeah, it's still the rest of the way, radical 2 to infinity. The rest of the way it's concave up, shaped like a cup. But now it's increasing and it's going through that x-intercept. Okay, so you notice right there and there and there is where it changed concavity and shaped the curve of the graph. So, we got a pretty accurate graph without using calculator, just using pre-calc and calculus stuff. That was super fun. Hopefully you enjoyed that too. I know some of these are long. I know. What, anything I can answer on that? Anything to review? I think I hit everything, didn't I? Did that. Okay, 5 points, sketch the graph. I also say this, if you still weren't sure about it, you could plot a few more points if you needed. If you want to know exactly where it's going through, plug in 1 and just see what the actual value is if you want a little more guidance. Agree on that? Okay, let's do one more on the next page. There's only 2 for this section. So flip it over, you'll notice it's a rational expression. Let's just start in with the pre-calc stuff. Let's start with the pre-calc stuff on this one. So, domain. All of the x values at work. So it's going to be all real numbers except what? Remember before break? Yes. So remember before break we talked about one of these. Yeah, 2. So you can say all real numbers x cannot be 2, or interval notation is negative infinity to 2 union 2 to infinity. Okay, range I'm going to have to come back to. Once we graph it, we'll just look at the y values. There's not really a good way to know what it's going to look like though now. So please just remind me, I'll have to come back to the range. I'm going to skip symmetry and let's go to intercepts. So y-intercept is when x equals 0. So in the numerator 0, 0, and 4. In the denominator 0 and negative 2. That would be negative 2. By the way, this will be a nice one on the grid. It's going to work out perfectly here. So 0, negative 2. Y-intercept. You know what? I think I'm going to write the full point there. 0, negative 2. Okay, x-intercepts are where the function y is 0. Now I'm going to solve this, and I really have to clear the denominator, and I'm just going to set the numerator equal to 0.
So you just plug 0 in for everything. For that one.
Yeah, yeah. And then I switch. So for this one, I plugged 0 in for x's. For this one, I plug in 0 in for y. So let's see. So yeah, so really, I'm clearing the denominator. The bottom is not going to give us anything, because when I clear the denominator, the left side will still be 0. And so now I just gotta solve this one. Factoring doesn't work. If you were trying that.
No.
Yeah, factoring doesn't work. I start to do the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. But what happens is I get inside the radical 4 minus 16, which is negative 12. And so there are solutions, but they're imaginary. So basically that means we get no x-intercepts. There's imaginary values for the solution, but no actual real numbers. So anyway, what I did there was, start to factor. Quadratic formula I can always go back to if it's an x squared. And if you, as you start to do it, it's just not going to work. Okay, that finishes up this. Any questions on the pre-calc part? So yeah, that's the only point I can apply. Okay, let's do the calculus part. So you do f prime and f double prime is a equals 0. I'm sorry, g prime, I guess. Okay. Well, it's a quotient. It's a fraction, rational expression. So we're going to do the quotient rule. So this will be a good review. Gf prime minus fg prime over g squared. I'm going to say it like this. Low, so let's see, low is x minus 2. D high, derivative of the high is 2x minus 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. minus the high, x squared minus 2x plus 4. And then d low is 1. Okay, all over the low squared. Let's see, low, x minus 2 squared. So I'm just going to simplify really the numerator, because the denominator is fine. And then I'll set it equal to 0. So in the numerator, I'm going to have to FOIL the first expression. So x times 2x is 2x squared. Then I've got negative 2x, and negative 4x, and then plus 1. Okay, here the 1 times the x squared minus 2x plus 4 is still just this. Doesn't really do much. I do need to distribute the negative. So negative x squared plus 2x minus 4. Okay, actually, some things cancel out. The 4's cancel, and the 2x's cancel. And then 2x squared minus x squared is 1x squared and minus 4x. Okay, now what I'm really going for to start is critical points. Alright, and then that will give me increasing, decreasing, and all the rest. So if you remember, when it's a fraction, a rational expression, you're trying to find the critical points, you set the numerator and the denominator equal to 0. Alright, you do both. So this will really get you, when you set it equal to 0, the stationary points, and this will give you what calls the singular points. So let's set the numerator equal to 0, and I can factor out an x. I'm just doing the numerator. And I'll go with x minus 4. And so there's x equals 0. And then over here I'll get x equals 4. So those are 2 critical points. And then over here, let's set the denominator equal to 0. X minus 2 squared equal to 0. Hopefully you can make a good guess that we're going to get 2, right? I can do a square root. This will be x minus 2, and this will be plus or minus 0, which is 0. And then add 2. So I'm going to throw it up here. Right, so 3 critical points, 0, 2, and 4. And yes, you need to make a number line, test values, and then what? Increasing and decreasing. So negative 1, 1, 3, 5. Okay, I'm going to plug these into the first derivative. And I'm going to do the simplest form. You can do any form. But the simplest form was this one. Once we reduced it all, we got down to there. Probably the simplest form there. So again, let's just plug in a couple here. So like 1. I plug in 1 here. 1 squared is 1 minus 4. And then down here will be 1 minus 2. That's negative 1 squared. So in the numerator I'll get negative 3. And in the denominator I'll get positive 1. And so that's a negative number. If I change it to negative 1, right here, negative 1 squared is still positive 1. Here though it'll be positive 4. Negative 4 times negative 1. Down here it'll be negative 1 minus 2, so now it's negative 3 squared, which is a positive 9. And that's still a negative number. Just for time's sake, you plug in 3 and 5 and you get plus and plus. No, that's wrong. Oh, I didn't change this one, did I? I'm silly. 1 plus 4 is 5. So it's 5 over 9. Jeez. Sorry about that. I said 1 plus 4, but then I just kept the negative 3. So when you plug in the negative 1, it was 5, and then negative 3 squared 9, so that's a positive number. Okay. Now when you plug in 3, yeah, this one's a negative and positive. Again, just for a time's sake there. Well, I'm going to write down increasing, decreasing. So, get rid of the test values. Let's see, what's positive? So negative infinity to 0. Ooh, 0. Union 4 to infinity. And then where it's decreasing 0 to 2. Union 2 to 4. First derivative test, I know local max and min. It's increasing, decreasing, and then over here it's decreasing, increasing. It's not going to look the same as the last one, by the way. We'll see why later. It starts. You think it's going to, but it's not. So local max. Let's get the point. So it's going to be at x equals 0. There's a local max. So there's increasing on the left and decreasing on the right. Let's get the point 0 something. And then local min will be at, over here it's decreasing and then increasing, so at 4 something. Let's go ahead and get those and plot them. We already know 0. That was the y-intercept. We already did it. One, the first thing we did. When you plug in 0, we got negative 2. So this right here is actually a local max. I don't know what this is. Let's plug in 4 to the original, just so we see what the local min value is. Okay, so when I plug in 4 up here, I get 16 minus 8 plus 4 over 4 minus 2, which is 2. So let's see, 8 plus 4, 12 over 2, and that's 6. 4, 6, 4, 6. Yeah, that'll be a local min. And then the global that goes along with that, global max and min. Let's come back to, because we don't know exactly what it's going to look like, what direction it's going to go.